So, triangles that are non-right angle triangles. If we're talking about the wave function, or we're talking about resolving forces into its vertical and horizontal components, then that's right angle triangles. And the ideas of Pythagoras, those sine, cosine, tangent ratios will be really useful. But there are situations where we have triangles that are not right angle triangles, and so we still need ways to find out missing sides or missing angles. And there are two rules that we use, the sine rule and the cosine rule. And here they are, the sine rule and the cosine rule. This cosine rule looks pretty horrendous, but actually it's not something you need to remember. We'll go through some examples. Both of these rules, the sine rule and the cosine rule, rely on a particular convention for labeling out the triangle, and it's set out here. If we look at it, we can see we've got the three sides of the triangle, and we've got the angles labelled A, B, C, using capital letters, A, B, C. That's the sort of convention. It doesn't matter which one you call A, which one you call B, and which one you call C. And then we label the sides A, B, C, but we use small case letters. It does matter where they go. Side A must be opposite angle A. Side B must be opposite angle B, and side C must be opposite angle C. That's the convention. And following that convention, these rules can then come into play. The sine rule tells us that the ratio of a side, so side A, divided by the sine of the angle opposite, that ratio of a side divided by the sine of the angle opposite is the same for all three sides. It's the same as the ratio of B to the sine of angle B, and side C to the sine of the angle C. Those ratios are all the same. So we can use that idea to help us find out information. If I know one side and I know the angle opposite, I know one ratio. So I can use the sine rule if I know a ratio. Used if I know a ratio. And by that I mean a side and the angle opposite it. So if I have a problem and I know one of those ratios, I say to myself, I can use the sine rule here to find this bit of information. And we'll look at some examples in a second. The cosine rule is used in other situations. It's a bit more awkward to use. So if I know a ratio, I'll always fall back on the sine rule. But if I have examples where, for example, I know all the sides, A, B, and C, small case A, B, and C, but I know none of the angles, by definition I don't know a ratio. So I can use the cosine rule to actually find out a missing angle. And if I know an angle and some sides, but I don't know a ratio, in other words, I know, say, angle A, but I don't know side A, I don't know that ratio. But if I know another side, then I can maybe use, or another couple of sides, I can use the cosine rule. And it turns out that if I know two sides and the angle between those two sides, then I use the cosine rule. Because if you think about it, if I know those two sides and that angle, I don't know a ratio. So I use the cosine rule. So those are the two rules. And there's two ways we can think of the cosine rule. One, if I want a side, and the other way, if I want an angle. And it just involves rearranging this top formula here. So there's a little additional exercise for those of you who are thinking about your algebra skills. Have a go at rearranging that top formula there to get this one. All I've done is rearrange that to get that. See if you can do it. But if you need to use it, you'd always be given those formulas, so don't worry about it. Okay, let's have a look at some examples now then of how we use those rules.